Everybody say hi, Husker Harvest Days people.
Hi, Michelle.
Oh, now they're going to be quiet. They were all pumped about it, and then okay. Anyway, all right. Okay, so yesterday we did all the heavy lifting. We did all the hard work talking about all the sorts of graphs that you can have that enlighten. Enlighten means give us more information that is good. It's telling good information, showing us things that we may not have seen if we just listed out the data. It's just nice, good ways of representing data visually. Because visual pictures and things like that are a lot less boring than just numbers, right? Okay. So graphs that deceive. This is the very back page of your notes. And what does it mean to deceive again?
To lie.
Kind of.
Hide info.
I'm gonna describe it kind of in different words than we did yesterday. So it's kind of as though to lead to believe things that are not true. When you deceive somebody, you are leading them to believe things that are not true. Okay, whether you're doing it on purpose or not, right? Some of these people may have good intentions when they create this graph, but they are actually making a deceptive graph that is not doing justice to the data. Okay, so I'm going to erase stuff here. Two of them, one of the main ones. One of the main forms of a deceptive graph is a non-zero vertical axis. We talked about that yesterday, but that's what it's called, a non-zero vertical axis, okay? That means, like these two graphs that we had over here, this one started at 10%, and this one started at 0. Which one is the good one?
Zero.
Right? We want it to start at 0%. So even though like we're kind of trying to save space, we are certainly allowed to do that little like blippy thing there. Yeah, you know, we've done that before already with our histograms. And we can certainly do that for the x-axis, but you never want to try to do that for the y-axis. You never want to start the y-axis at anything other than 0 because it stretches things out and it makes things look as though they're conveying false information. Okay, so we can use this on the x-axis to start, but we cannot use that on the y-axis. Okay, so what was the problem with starting at 10%? Do you remember from yesterday? Like these two graphs are doing the same thing. This is the same data. Right. So the placebo here, this was at like 11%, and this one was at 23%. But 11% is a little less than half, but about half of 23%. But that bar looks way less than half, right? So it's making it look as though the Oxycontin or the pain medication is doing way more for you than what it should, right? If we look at the actual graph of what it should be, this is still 11%, this is still 23%, but now it doesn't look as drastic of a difference, right? Do you see how that could be deceiving? Yes? Okay, so that occurs when you have a non-zero vertical axis. You don't ever want this. Don't want. You can have a non-zero x-axis or horizontal axis, but you don't ever want a vertical axis that is starting at something other than 0. Make sense? Okay? All right, let's go on down. I'm not going to read this whole paragraph because we don't want to do that. The last thing before our concluding thoughts is a pictograph. And sometimes they'll like do this in elementary school because like kids like to look at pictures rather than looking at, you know, a bar graph, okay? But pictographs use caution because usually pictures are like three-dimensional figures, okay? And so, or even pictures like these two pictures are two-dimensional, right? We have a width of the cigarette and we have a length of the cigarette, right? Okay, so what we have going on here is that this one says in 2013, 18% of U.S. adults smoked. 2013, it was 18%. But in the 1970s, 37% of U.S. People smoked. Okay, I'm just going to write that a little bigger so that we can see that. So nowadays, or at least in 2013, it's half of what it used to be, right? A little less than half of what it used to be. Actually, yeah, a little less than half. 18 doubled would be 36, so it's a little less than half. But this cigarette, to me at least, looks more than half of what that, or It doesn't look half the size of the other cigarette. To me, at least, it doesn't. Why doesn't it look half? Like it might be half the length, right? Yeah, it's a two-dimensional figure. So it's like the area is not the same. Like this area is not going to be proportionate to that area. If we're just looking at one-dimensional things like lines or bars, sure. But this one has two dimensions, okay? The larger cigarette appears to be 8 times as large as the smaller cigarette. So this one is actually times 8. Why? Because it's two-dimensional. Because two-dimensional. Does that make sense? The larger cigarette appears to be 8 times as large, right? Okay, so let's just put some numbers to this. I'm going to do this in a different color. Let's say the cigarette is a 1 by 8. So it would have an area of, like it's a rectangle, right? 1 by 8 would have an area of 8, right? But if I double this length here, what would the bottom side of that cigarette be? 2 by 16. What's 2 times 16? That's 32, right? So really, we're looking at an area of 8 versus an area of 32, which is actually only 4 times, but they're taking into consideration this is a 3-dimensional figure, so it has width as well. So if you're just looking at 2 dimensions, it's 4 times, but if you look at the 3rd dimension, or like the width of this cigarette being the same, it would be 8 times. Does that make sense? Okay, so be careful, use caution when you're using pictures, especially if they are like 3-dimensional pictures, okay? You could use circles or you could use boxes as long as they're not 2 or 3-dimensional figures. Make sense? Okay, like 3-dimensional would be like a box that looks like this. You don't have to draw this. Versus a box that looks like this. Right? This volume is going to be way more than double what this volume is. Okay? So be careful. Use caution when you're using multi-dimensional figures to represent data, because that can be kind of deceptive. Okay? Happy with that? Concluding thoughts. For small data sets, 20 values or fewer. If it has fewer than 20 values, don't put a graph to it. Just use a table. Don't use a graph. No graphs. If it's 20 data values or fewer, no graphs. We're going to kind of break that rule when we graph some of this data, because there's only 17 of you. So we're going to kind of break it a little bit. But next week when I have you guys graph your pulse and that type of thing, just use a table instead of a graph if there's less than 20 people. A graph of data should make us focus on the true nature of data, not on other elements such as eye-catching but distracting design features. Okay? You guys are fine when you use like different colors. I think that's helpful. But if you're like, you remember in elementary school when you did like, one of the bars was this, and one of the bars had dots on it, you know, and one of the bars was shaded this way, you know, like that's kind of a little bit more distracting than it is helpful, right? I would say colors are fine, but if you're doing extra designs in there, don't bother with doing that because it's kind of distracting for the data, okay? We want to focus on the data and not on the design. So a graph of data should make us focus on the true nature of data, not on other elements such as eye-catching but distracting features. Okay? I would almost argue that this cigarette thing is doing that same thing. I'm more focused on like, oh my gosh, there's a cigarette on the paper, rather than like the data that it's trying to convey, right? Okay, number 3, do not distort data. Construct a graph to reveal the true nature of the data. This is like starting at a non-zero vertical axis. So don't start at values other than 0. Okay, that's kind of what that 3rd bullet point is trying to get across. Don't distort the data or construct the data to reveal the true nature of the data. And the last one, almost all of the ink in a graph should be used for the data, not for other design elements. That kind of goes along with, you know, creating the design. Okay, don't put too much flair and, you know, whatever, which I haven't seen you guys do yet. So Who?
It was colorful. and
Lilies?
pretty. Thank you.
I think the color is helpful though. I think I like the color. I think it's helpful to me, especially if she's doing like when she goes through her data. So like she did like a highlight thing where like numbers 190 through 200 are in yellow, numbers 200 through 210 are in whatever. Well then if I have that data set that goes with the graph, I can see, okay, yellow, yellow, or orange, orange, you know, like together it kind of makes the full piece. And so I like the colors. Designs, that's a little too much, but I like the colors. I think the colors are kind of helpful. So if she wants to keep doing colors, all power to you. That's not to say like if you're using a pencil, that's bad. Like I don't care. But make sure that we can still read it and still, you know, everything's good. What? It's just not as good. Okay. All right. Anything else we need to add? This is not too bad, right? Not too much notes today. I'm going to post your homework assignment here in like 30 seconds. Well, don't time me, Caleb. Give me like a minute and 30 seconds maybe. Okay, I'll post it and then you can get to working on that. And we'll call it kind of a Friday, right? Yeah. Okay, everybody say bye.